Now we're going to do 3 more problems involving linear functions. Given 2 lines, we're going to find their intersection. Given 2 lines, we're going to test whether or not they're perpendicular. In this case, we're going to show that these 2 lines are perpendicular. And given two points for a line and 2 points for a second line, we're going to show that the lines passing through those points are perpendicular. Okay, so let's do it. Let's work in yellow. Find the intersection of the lines y equals 4x minus 5. So just sketching over here, any 2 lines, if you see where they intersect that their y values are equal, for some given x value, they have the same y value. Okay, so their y values are equal. So here's our y, here's our y. So we set those 2 equal to each other and see what x value pops out. So as y, so we set this y equals 4x minus 5. So 4x minus 5 equals this y, but this y is a negative 3x plus 7. And now we just solve. Adding 3x to both sides, I get 7x, and adding 5 to both sides, I get equals 7, 8, 9, 10, 11, 12. Okay? So again, that is I added 3x to both sides to bump this 4 up to 7x, and I added 5 to both sides to cancel that 5 there, and it bumped that 7 up to 12. Now dividing both sides by 7, you get that x equals 12 sevens. Now I can plug that x coordinate into either one of these linear functions and it will give me the y value. We'll plug it into both just to show that it doesn't matter which one you plug it into. So let's plug it into this one. Y equals 4 times 12 sevenths minus 5. Over here, well, let's just work it out. So y equals, what's that going to be? 48 sevenths minus 5. And 5 is going to be what, 35 sevenths? And so what do we get? What's 48 minus 35? 13? 13 sevenths. Now let's plug it in the other one. Plug it into this one. Got purple, we'll say y is a negative 3 times 12 sevenths plus 7. So y equals going to be a negative 36 over 7 plus, I got a 7, I got a denominator of 7, so I need 49 sevenths. And we're going to get 49 minus 36 is 13 sevenths. And we see in both cases here, I let x be 12 sevenths and I got y to be 13 sevenths. X is 12 sevenths and y is 13 sevenths. So just demonstrating that it didn't matter which ones we put it in. So our solution is going to be 12 sevenths and 13 sevenths. That's where these 2 lines are going to intersect. Okay. Next problem. Show that the graph of the 2 given linear functions is perpendicular. So the graph is perpendicular. So to show that 2 functions are perpendicular, from your readings, you should know that we need to show that m1 times m2 equals a negative 1. Okay? So we just need to find m1 and m2. So from here, let's get the m1 equals 4. From here, let's get the m2 equals a negative 1/4. So we look at m1 times m2 equals 4 times a negative 1/4, which does indeed equal a negative 1. Therefore, simple process to test if two lines are perpendicular. Find their slopes, multiply them together. If you get -1, perpendicular. If it's not -1, they are not perpendicular. So these two were. One more here. And this one we're given the points. We're given that a line passes through these 2 points, and we're given that a line passes through these 2 points. And we want to show that those 2 lines are perpendicular to each other. So all I really need to do is find the slope of each line. So let's do that one in yellow there. Let's say M1. M1 is going to be, what, 7 minus 2 over 3 minus 1. So M1 equals 5/2. Okay. Get that one in magenta. Let's say right here, say M2 equals 5 minus 3 over 4 minus 9. M2 equals -2, 4. So 5 minus 3 is +2, but I know this bottom down here is negative, so that's why I had made it negative. 4 minus 9 is what, -5? Okay, so now let's check and see if they are perpendicular. Check. And we want to look at M1 times M2. That's going to equal 5/2 times a -2/5. Alright. See that the 2 cancels the 2. And the 5 cancels the 5. And so we get that this equals, and there's the negative, so we get this equals -1. Therefore, the 2 lines are perpendicular. Okay, that's going to conclude this video. Thank you.